Good morning, this is Dr. Turner for Integrated Math 1. Today we're going to be looking at 7.2, which is looking at angle measurement and angle bisectors. Starts out with a little bit of review of angle measurement, how we measure angles using a protractor, and then we get into angle bisectors, the definition of that, and how we determine angle measurements using the definition of angle bisectors. So to start out, we usually use a protractor, which is what this tool is called, to measure an angle measurement. And we're used to looking at, let's say, a smaller angle. So if I had a line drawn here and I had a line drawn, let's say, here, we're used to looking at that angle measurement and just automatically saying, okay, well, look between the lines, right? That means that this angle is 40 degrees. However, when we look at an angle that is drawn particularly against a linear diagram or a line, we are actually creating two angle measurements here. So yes, there is an acute angle there that is 40 degrees, but when you draw that line segment opposite from the original line segment at the bottom, you're actually creating two angles. You're creating 40 degrees, but also here for the larger angle, you're creating 140 degrees. So if you notice, looking at the protractor, there are actually two angle measurements here, which is why there are two. You are looking at both the acute and the obtuse angle obtained. So there are a couple questions that involve that, just using a protractor correctly. So be aware of that. You're also asked to define angle measurements that are given to you. So you have a couple different ones. The first, of course, is an angle measurement that is less than 90 degrees. An angle measurement that is less than 90 degrees is acute. For a point of reference, if we're looking at angle measurements, an angle that is 90 degrees forms a right angle or a square with the two sides. So that is a 90-degree angle. That is your right angle. And then any angle that is smaller than that is an acute angle. And any angle that is larger than that is greater than 90 degrees, then that is an obtuse angle. So you have acute angles, you have right angles, and you have obtuse angles. So those are the three you want to be familiar with based on angle measurement. Again, when you're measuring an angle with a protractor, unless it's 90 degrees where you end up with two 90-degree angles, other than that you're going to end up with two angles, one that is acute and one that is obtuse. So part of your assignment for 7.2 is also being able to identify the type of angle based on a diagram. And then the other thing that you are introduced to in 7.2 is what's known as an angle bisector. So just like a midpoint, where a midpoint was the point that divided your line segment into two equal parts, an angle bisector is a line segment that divides your angle into two equal parts. So rather than looking at line segments and distance, we're looking at angles here, and if I define, and we can label this, let's call this larger angle ABC, and let's call the angle bisector that's cutting it in half BM. If I define BM as being the angle bisector, that means angles ABM here and MBC are congruent. They are the same angle measurement. So there's a couple of types of questions I could ask you based on angle bisectors then. For instance, if I say that the measure of angle ABC is 140 degrees, I could ask you, what's the measure of angle ABM? Now, if BM is given as the bisector, that means it's cutting into two equal parts. Therefore, ABM would be 70 degrees. Similarly, if I asked you for the measure of angle MBC, half of that would be 70 degrees. And I could also go the other way. Let's say I told you that the measure of angle MBC, given that BM is a bisector, is 67 degrees. Well, then based on that, if I asked you for the measure of angle ABC, that's twice as big as the smaller angle, so double 67, you'd get 134 degrees. Now, some of the questions are as simple as that, either doubling or taking the half of the larger angle. You'll also have a couple questions where you'll be given algebra instead of integers and be asked to solve for the missing variable. So for instance, if I say the measure of angle ABM is 3x plus 100, and the measure of angle MBC is 2x plus 180. Okay. So if I give you those two angle measurements, then you need to use your properties of an angle bisector to be able to solve for the missing variable. Now, because BM is defined as the angle bisector here, that means ABM and MBC have to be equal to each other. So I would set this up as an algebra problem. 3x plus 100 equals 2x plus 180. Subtract 2x on both sides, so x plus 100 equals 180. Subtract 100 on both sides, that means x equals 80 degrees. Okay. Now, as always, remember that the diagram is not necessarily to scale, so you're going based on the given information, not what the diagram looks like. So just keep that in mind, but this is essentially what you're doing for 7.2. That's it for today, guys. If you have any questions, please reach out to me. Otherwise, have a good day, and I will talk to you soon. Bye.